Hello friends, welcome to Com Connection. I am Devesh, your friend and tutor, and we are back to the fifth lecture in continuation with the lecture series of engineering mathematics, and we were doing matrix. So in the last lecture we were done up to echelon form of a matrix. So now we will see linear dependence. So considering the vectors x1, x2 up to xn are said to be linearly dependent if there exist are numbers lambda 1, lambda 2 up to lambda r. If there exist r numbers, these r numbers are lambda 1, lambda 2, lambda 3, lambda r, not all zeros. This is very important. All the lambdas must not be 0 such that this equation is satisfied. The equation is lambda 1 x1 plus lambda 2 x2 plus lambda r xr equals to 0. अगर ये equation satisfy होती है तो the vectors are said to be linearly dependent. If no such number other than 0 exists, the vectors are said to be linearly independent. अगर हम ऐसे lambdas नहीं फाउंड कर पाते तो the vectors are said to be linearly independent. Okay. Next is coefficients and augmented matrix. So let three linear equations दे रखी हैं. a1x plus b1y plus c1z equals d1, a2x plus b2y plus c2z equals d2, a3x plus b3y plus c3z equals to d3 be a system of linear equations. Then matrix A matrix which is made up of placing the coefficients of x, y and z, not x, x, y and z of all these three linear equations in the form of rows. सारे coefficients को rows की form में r1, r2 and r3 place कर दो और एक matrix बना ली A. Is called a coefficient matrix. This is a coefficient matrix of the system of three linear equations. And the other matrix B is a1, b1, c1. This is same as A, but the fourth column includes the constants d1, d2 and d3. This matrix is called augmented matrix. Why is it called augmented matrix? Because this is A augmented D. A is the matrix having A1, B1, C1, A2, B2, C2, A3, B3, C3, and the fourth column is D1, D2 and D3. This is the notation of augmentation. तो एक 3 cross 4 matrix which includes A matrix and the fourth column as the constants. This is called augmented matrix. Next is solution of linear system of equation. So there are various methods to solve linear system of equations. First is Cramer's rule or method of determinant. ये आपने 12th में भी पढ़ा होगा. So according to Cramer's rule, considering the three system of linear equations, let del be a determinant of coefficient matrix. Coefficient matrix बना ली having coefficients of x, y and z of all the three system of equations respectively placed in the form of 3 rows. तो del है a1, b1, c1, a2, b2, c2, a3, b3, c3 का मैट्रिक्स का determinant. Since it is a determinant, it must be have some value. It must be having some value, say anything This is del. Then say x is equals to first column of del को इंटरचेंज कर देंगे d1 d2 d3 से. x इज डेल वाले मैट्रिक्स में फर्स्ट कॉलम को के एलिमेंट्स को हम रिप्लेस कर देंगे विद द कांस्टेंट d1 d2 and d3, and when it is divided by del, this gives x. Similarly, for y, del वाले मैट्रिक्स में सेकेंड कॉलम को हम d1 d2 d3 से एक्सचेंज कर देंगे. When this is divided by del, then the answer is y. Similarly, for z also, if the third column is replaced by the d1 d2 and d3, and when divided by del, then the answer gives the value of z. So by this way we can solve for x, y and z, and this is Cramer's rule. Example. This is example 10. Solve the equations. 3 equations are given and we have to solve these equations by Cramer's rule. So इन्होंने पहले del निकाला. Del coefficients of all the equations 3 1 2 3 1 2. The next row is 2 minus 3 minus 1, 2 minus 3 minus 1. The third row is 1 2 and 1, 1 2 1. This is del. When solving this we get 8. X is first column is replaced by constants which are on the RHS 3 minus 3 and 4. First column is replaced by 3 minus 3 and 4. When divided by del is 8, we get 1. So the value of x is 1. Similarly for y and z, we can get their respective values. So the answer is x equals 1, y equals 2, z equals minus 1. So this is one way of solving system of linear equations. Next is matrix inversion method. ये 12th में भी पढ़ा था. तो system of 3 equations. A is the coefficient matrix. Capital X is a 3 cross 1 matrix X, Y, Z, and D is 3 cross 1 matrix having the constants D1, D2 and D3. So we can write AX equals to D, multiplying both sides by A inverse. A inverse AX equals A inverse D. We know A inverse A is I. So I into X equals A inverse D, or X equals to A inverse D. Placing these matrices X, Y, Z can be solved by this equation. A inverse is, we all know, the adjoint of A divided by determinant. Del stands for determinant. A inverse is adjoint of A divided by the determinant into the D matrix. D matrix is D1, D2, D3. You must have studied this method in class 12th. Here is an example. In this example, the 3 system of equations are solved by matrix inversion method. You can have a look out of this example. Next is a theorem. If A is a non-singular matrix, then AX equals to D has a unique solution. If A is a non-singular matrix, यानी मैट्रिक्स A का डिटर्मिनेंट 0 नहीं है, तो Ax इक्वल्स टू D का जो सॉल्यूशन है वो 1 होगा. इट मस्ट हैव अ यूनिक सॉल्यूशन, यानी एक्स वाई जेड की जो वैल्यूज़ होंगी वो यूनिक होंगी, एक से ज़्यादा वैल्यूज़ नहीं हो सकती. नेक्स्ट टॉपिक इज consistency of linear system of equation. This is also a very important topic. So considering m linear equations, say a11 x1 plus x12, not x12, it is a12 x2 plus dot 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 plus a1n xn equals to k1. Other equation is a21 x1, and similarly this is up to m. So there are m linear equations, am1 x1 plus am2 x2 plus dot 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 amn xn equals to kn. So there are total n number of variables, x1 x2 x3 xn. So these contains n unknowns, x1 x2 x3 up to xn. So to determine whether the equation first are consistent, that is possess a solution, or not, we consider the rank of the matrix. इन सिस्टम ऑफ लीनियर इक्वेशंस की कंसिस्टेंसी देखने के लिए हमें पहले इसकी रैंक निकालनी होगी. सो वी विल मेक अ मैट्रिक्स ए, अ कोफिशिएंट मैट्रिक्स रादर ए, containing the coefficients a11 a12 up to a1n. Similarly the second row a21 a22 up to a2n, and the mth row am1 am2 up to amn. And k is the augmented matrix जो मैंने पीछे बताई थी. A augmented the constant column k1 k2 up to km. This is augmented matrix. So A is the coefficient matrix and K is called the augmented of equation I. So this is consistency of linear system of equation. So according to the Rocchi's theorem, the system of equation is consistent if and only if the coefficient matrix A and the augmented matrix K are of the same rank. System of equation तभी consistent होंगी जब A और K की rank same हो. The matrix A having the same rank equals to the augmented matrix. Otherwise system is inconsistent and the solution will be unique only when r equals to n. Why r equals to n? This is r. This is the rank of A matrix. This must be equals to n. Hence the equation are consistent. So according to Rocchi's theorem, equation is consistent if and only if the coefficient matrix A and the augmented matrix K are of same rank. अगर इन दोनों की रैंक सेम है तो वो कंसिस्टेंट होंगी, ठीक है, और अगर रैंक सेम नहीं है तो इनकंसिस्टेंट होंगी. और जो कंसिस्टेंट हैं, those equations have a unique solution only when rank is equals to number of unknowns. अगर rank 3 है और number of unknowns भी 3 है तो the system of equation has unique solution. सो जो कंडीशन जो हमें रिक्वायर होंगी फॉर यूनिक सोल्यूशन एंड कंसिस्टेंसी इज rank of A should be equals to rank of K, which is also equals to N. This N is number of unknowns, or you can say number of columns of A. So this is Rauch's theorem. Okay, this is all for today's lecture. We will see procedure to test the consistency of system of equation in n unknowns in the next lecture. Thank you for watching the video. Please do like, share and subscribe.